I'm the single layer associate product line manager for Knowles capacitors, Knowles Casnovia. And really this is going to be just a presentation about the products that we offer, a couple slides on some of the capabilities that we're working to improve, some of the manufacturing stuff, and then also some test capabilities. And I also didn't put in the presentation, but I have a new product that I wanted to show you, a data sheet for the V series that we're releasing. This is a pre-release document, but it's something that we'll have confirmed and provided out to everyone shortly. But so
also, before we begin, real quick, I do want to let everyone know too that everyone's going to be muted. If you do have any questions, feel free to just type it in the chat. I'll let Ian know if any questions pop up. Sorry about that. I just wanted to kind of let everyone know that too. So
exactly, and we can I can stop and ask questions. We can ask questions per slide. Doesn't matter. Interrupt me within the conversation. I'm really flexible on this. I want this to be somewhat of an open dialogue. Make sure I hit any of the questions. I know a lot of this is probably a review for pretty much everyone. Single layer, just to kick it off, single layer capacitors. Knowles has been making single layer capacitors for 30 plus years, even probably longer now. It's what Knowles or Dielectric Lab was founded on. And we really branched off and really moved into different products of thin film and couplers and filters and power dividers now that you've probably seen more and more of. But this is the foundation of what DLI was founded on, and it's our bread and butter. It's really what we hold our hat on, and I really enjoy talking about it. So we'll talk a little bit about it and have any questions. So I'll skip over this. So really what everything starts is with the dielectric labs, the dielectric material. That's why we called ourselves DLI. We manufactured these class 2 and class 1 and class 3 materials over the years. All of these are in-house formulations. We have over about 40 different dielectric formulations internally. We make it. We start from a raw powder form, and then we mill it, we tape it, we dice it, and we fire it. So it's all done here in the facility at Cazenovia. One of the things that makes us unique is that we can really kind of customize the dielectric constant that we're looking for, the pH level, the viscosity of the part, really hone in what we're looking for. One of the things that our customers typically come for is a high dielectric constant, which you can see is in the UX and the BV material in the class 3s. That allows you to get a very, very small part with a larger capacitance, or the same capacitance in a larger part. So as things go and we move to smaller sizes on equipment and applications, this is typically a good way to reduce the footprint of the capacitor. You're not really losing anything from a TC, a temperature coefficient. As you can see, the UX is a 25,000 dielectric, but we're also still in an X7R material. You still have a good dissipation factor at 2.5, and your insertion insulation resonance is still high. Not as high as the other ones, but it does do a good job. These are pretty much. Anybody have any questions on the materials? I think that the key takeaway here is everything is made in-house, and that's we don't rely on other companies to make materials, to buy material from other companies. We do some of that with the Compex brand on the class 1 materials on the next slide, but everything from on this slide, besides except the PI, the alumina, is made in-house. Cherian is our applications engineer. I want to introduce him as well. He's on the call. He has a background in ceramic engineering, and actually was our ceramic engineer prior to being the application engineer. And he has a pretty vast knowledge of actually help make some of these materials. So if you have any in-depth questions about that, Cherian would definitely be your guy on this. All right, well, let's just move on. So Compex materials, when we when I say Compex and DLI, so what we purchased Compex in 2018, and we transitioned the facility into Casanova in 2019. What we do, and they do run a similar path of manufacturing, however, they do go down different paths for visual inspection and testing. So we consider DLI more of the military high grade capacitors and Compex more of the commercial grade capacitors. So you will see a price difference there, and typically majority of the price difference is due to the visual inspection or the test requirements done from part to part. Some customers are commercial; they don't require a 100% test or 100% cap. They don't want they don't need 4-sided visual inspection. They just need 2. And some of our military customers even want the 6 instead of the 4. So it really depends on the customer. Typically, the way that we guide customers, if you are a military defense or aerospace customer, you want to go with the DLI brand, and the Compex is more commercial telecom brand. But in the same token, we've had some military customers and really wanted the Compex brand, just from a legacy perspective, because they had worked with Compex in the past. So in this slide, we're seeing a PCN notification. When we did the transfer in August of last year, we noticed that there was 3 dielectric materials, C70, C90, and C130. All those got transferred into our DLI materials. We felt there really wasn't a need to make 2 of the same materials. So that has gone through. It's been pretty insignificant. A lot of the material was a little bit of a low runner, so that's why we did it as well. It wasn't a big hit. The one that you don't see on the DLI side that you will see on Compex is the C400. That's a 35,000 K dielectric. Everything else is pretty much similar or the same. We don't offer that in the DLI side, but it is something that we offer on the Compex side, and really has to do with the firing and sintering stages within the C200. It's very similar to that process, just to get the K up. That's it's more. Cherian, actually, is it the back oxidation process that they do?
Yes, it's controlled by the back oxidation process and the
Gotcha.
grain control.
Yep. Okay. So that's really, it's very, very similar. We don't offer it. I mean, really, if someone wants that high K, it's typically for the telecom industry anyway. So that's typically what we see. All right. So single layer capacitor is a single piece construction, but there is metallization on each side. It's we do 2 types of metallization. We use a sputtering and we do a wet plating. Typically, we have about 5 or 6, maybe even 7 now, different sputtering machines with 3 to 4 chambers in each sputtering machine. Our typical metallization is a tungsten gold. It's that S5 right here. This one. We do S1. Gold, nickel, vanadium, and tungsten. Tungsten is always our seed layer. It's the hardest, it's most abrasive seed layer, so it sticks the ceramic better. We do, for the etch plated, we do nickel gold. I think it's 50 microinches of nickel and 100 microinches of gold. Seems to be good. We don't really have too many complaints about that. So, but typically, we try to direct our customers to sputter plating. It seems to be it's more controlled process. Electroplating is typically a legacy product, or somebody that's, that really is stuck on it and really wants to do it that way. So, and also Compex. What I don't mind using the Compex. So Compex has a Toolpath gold. What they did years ago is they went to a tungsten platinum gold metal stack, and why they did this was because it could be either wire bond or solder. They didn't really have to change the metal stack on this. You can do either or on it. What it didn't really mesh well with our manufacturing process for DLI, because what we do is we do a lithography process, which doesn't go well with platinum. Compex use what they call a scoring process, and basically it's a skim dice. They dice their borders around their parts, and that's fine. I mean, with a commercial application, you don't really need the clean edges as much as you do in the defense market, where we would do litho and it would be a little bit cleaner. So that's why we go with the titungsten gold and instead of the Ti-Plat gold. But with Compex, the commercial products, we still do Ti-Plat gold on all Compex. Majority, we didn't change the metal stack. We don't really have problems with it. However, we have seen in some of the issues where some of the larger bar caps, where I guess the flexibility or the weakness of the ceramic has an issue with skim dicing the larger the part. So the larger the part, the more I recommend going to a lithography process. It's less abrasive on the ceramic, and you're not dicing through the metal.
Or even on a thinner substrate.
Yeah, that's a good comment, Shane. Yeah, on a thin. So if you're going a 4 mil substrate part, we're gonna want you to do a lithography process and not the skim dicing. Okay, here's a little bit more. So Compex, one of the benefits. So Compex really, they customize their stuff all around the LC filter market market, and when the LC filter market, they basically were like, in our sense, it's like Burger King, right? They're gonna have it. You're gonna have it your way. The customer's always right, no matter what. You want a 11.5 to 100.5 width and length, and you need, all these different requirements and customizations. Compex was there to give it to you. And we've adapted that model. We understand that market, that they need that. The capacitor is really there to support the LC filter construction. So we get it, and that's what we support that market as well. But that's the reason why they had so many different metal stacks, and they also had so many custom part numbers. So DLI, you'll see a big difference between DLI and Compex is DLI is more standard. Hey, this is a D20, it's 20 by 20, and you're going to get this metal stack, and this is the part that you're going to get. Whereas Compex, it's basically you come in, you customize your part the way you want it, the way metal stack you want, the way, the size, the length, width, and height, and it's up to you to determine. So there's pros and cons to that. Obviously the pros are that it's customized, but with doing it that way, they do a lot of skim dicing, whereas you won't get that lithography process because we're not going to buy mass for every custom job out there. You're going to get a skim dice part. Now this is the metallization goes stack by stack. There's actually, if you look at the Compex metallization codes, there's like 300 of them. So there's a lot of them out there. Any questions on just the overall processes and the different types of brands so far? Okay. All right, so die cap. We'll go into the product. So die cap is just basically a square on two metallizations on each side. Really, it's used for DC blocking, RF bypassing, filtering, coupling, tuning. One of the key features of the die cap is it's customizable. You can really make it any way you want. There's no mass. There's no any real kind of limitations to this. I mean, there are some aspect ratio sizes for it, but really it's not that much. We can really customize it to the customer's liking and what are their application. And since the application really determines a lot of the feasibility of the part, we really do look for the customer's input on that. I mean, there's so many different ways you can use this and different types of the thickness and the size of the part. It's really we have design tools for this now, so it's all on our website. You can go on there and just put in what you're looking for, and it's all right there for you. Same with this. So the Compex is, so if you look at this, the Dielectric Labs is a die cap, and Compex calls it a CSA, a series edge-to-edge capacitor. It's the same thing. The only difference is one's commercial, one's non-commercial, one's defense or military. And this is, in this blurb here, it kind of goes into the LC filter market with the custom caps, and that's really one of the main reasons why I like that. I like that the customer is able to provide us with their exact spec requirement, and then we'll design that for them. DLI is typically more on a program based. We work with the customer a little more, where as in Compex, you guys, the customer can tell us whatever it is, and we kind of get it done. All right, border cap. I say, if I was kind of giving you a kind of landscape of the product line, DLI border cap is probably the #1 seller out there. We typically sell the most out of this, and then the second would be the SLC die cap for Compex, and so typically the commercial side, they don't care about a border. They're not going to really use that, and they don't have an issue with the attachment process for shorting out the cap. So they'll just use it on a commercial side, and they use it in high volume. And the border cap really is what the military defense market will buy. And it has epoxy and solder attachment process, and you put the border around it, and it prevents it from shorting out during the attachment process. So it's a little bit safer, prevents any rework or any issues like that. Same applications, same functional use, DC blocking, RF bypass, filtering, tuning, and coupling. The other thing to note is that the voltage options, 100 to even do 200 volts. And if you need something higher than that, definitely shoot us an email. We can discuss that. That's not just the end of our capability. Something we can work with. Cherry and myself can review the specs and see if it's doable. The same thing, margin caps. So Compex does margin caps, but just not on a more regular basis. The same thing. All right, bar caps. So bar caps is just a capacitor and multiple capacitors lined up in a single array. We do sell quite a bit of these, and I'd say this is probably one of DLI's higher runners as well, right behind the border cap. It really has a lot of benefits to it. A single insertion reduces complexity and cost, so you're not putting down multiple caps. You got all of them, and you're just putting down one, so you're saving time on assembly. You have the gold metallization for wire bonding, and you're reducing bonds, so improve performance on that. The customized solutions, we do that as well. I think this would be the most customized solution that we offer for DLI. We really have a lot of different ways. I don't typically see a single way of doing this. Typically, the way it goes into construction is the customer will provide us their specs, and then we'll design the bar cap to the customer's liking. They'll give us the aspect ratio, and then we do the rest, or vice versa. We do roll capacitors for the Compex side, a lot less. We actually probably push people more towards the DLI bar caps because like I said prior, skim dicing row caps is pretty tough, and also the yield is pretty low on these. So we like to do the lithography process. So tie-plat gold on a row cap is not something I like to do. If you guys have had customer orders that are legacy, then that's fine. but we tend to steer people towards the DLI brand on that one. Gap cap. This is basically it's configured capacitor for microwave applications. Some of the benefits of a gap cap are eliminating wire bond. It has. Oh, sorry. So I forgot to put myself in presentation mode. Hold on. Okay, sorry about that. All right, so again, customized solutions. The availability for it's up to 800 picofarads, so not as high as the other capacitors, just by the nature of the design. But operating frequency is up to 30 gigahertz, just like the others, even higher. I mean, the same as the bar cap. We offer customized solutions, DC blocking, RF bypass. Really, the benefit here is it eliminates wire bonding, has a gap on the bottom side of it, and you attach on each side in a microstrip or I believe it's strip line circuitry. Again, same thing here. Dual pads, same thing. We really tend to steer people to the DLI one on this. All right, V series. V series is so. Just to kind of a little segue into that. So we have our standard single layer capacitors that we sell every day, and we love them. But we've in the recent years been focusing a little bit more on DC blocking and high performance DC blocking and bypass capacitors. And the next few slides is what you'll see a product of is we've designed some higher performance parts that aren't your typical just single layer capacitors like this one. So a V series part really is made for a bypass capacitor and shunt to ground. And a lot of MMIC designers use this or use some form of it. There's some competitors out there. The Presidio has a very similar part to this, but we outperform them in some specific ways. And also, it's a needed, as applications and the MMICs go higher in frequency, these parts are needed. So it's something that we definitely felt that there was room for growth and opportunity to win market share from the customers. So to give a little bit more about this is X7R temperature stable, has excellent high frequency response. I will show you a data sheet for this actually right now. So this is the vertical electrode data sheet. A lot of this is about the V80, the 100 nanofarad one that we're just releasing. However, we do show the V30 on here as well. This case size is not right. This should be a 4, but I pulled the older version, so don't look at that. But it's really, the main part of this is used for RF bypass. Has an excellent high frequency response. It's wire bondable. So that's really, we've seen a lot of customers use that. The reason why they're moving towards that because it's for wire bondable, and has the highest capacitance and the smallest footprint. So here's a few of the capacitance values as the frequency gets higher, and the capacitance gets higher, the inductance and impedance gets lower. So that's always a good thing. Your tolerance is 20%. Your voltage rating. So this is really where we outperform our competitor. Mainly is the voltage rating. Presidio doesn't really have anything in the 25 or 50 volts for the 100 nanofarad. I think there's at 16 or lower, and we have a competitive advantage there. We're same size, and we're about the same price. So really, it's as the voltage rating is requirements are higher, our part is more tractable. And this is some of our performance data on the insertion loss. Okay. So we're showing DC blocking and RF bypassing, but we typically don't see any applications use it for DC blocking. They're going to use more of a surface mount technology on that for that, which would be our next one. So this is what typically used for DC blocking, the millicap, and this is a really good. We really have a lot of success selling this. We typically see this in the military defense market where they don't have to go in the kilohertz. They don't have to DC block that low. Where this goes to, I think it's 100 megahertz. Cherian, and you've been testing these pretty frequently, right? 100 megahertz is where the line is for these.
Yep.
Yep. So this goes from 100 megahertz to 50 gigahertz DC block, and this typically has it's a solder surface mount, so that's an attractive. You don't have to wire bond to it. It has really good performance. Like I said, ultra high series resonance, very low series inductance. So I mean, it's just a really, really great part. It's low, it's a high Q part, low loss. So here's some of the data that we can provide to the customer. So if the customer needs the DC blocking past the 100 megahertz, we recommend we have an option for them, the OptiCap, and that's basically just puts an MLC on top of the single layer capacitor, and it blocks all the way down to 16 kilohertz, and that typically we do sell this in the optical market. However, it is more of an expensive part, so typically something to be aware of. But it is we make it. We don't have too large orders with it, but it is something that is there and feasible for anybody that would like to try it out. Testing capabilities. We've been known for this. I mean, this is probably one of the cornerstones of DLI. Is we have life testing equipment right in house. We can do 1,000 hours and 2,000 hours life testing. We do class group A, group B, class H, and class K. We really have all those testing capabilities in house. We do some outsourcing, but it's very, very rare that we have to. Typically, it'll be some abnormal tests. Like we just had one come in, it was like a board flux test that we might have to do outsource, or we will have to, build the test fixture in house. But typically, any type of standard reliability testing we've done in house, and we've done for many, many years. We have a lot of reliability data by ceramic lots, and we've hold those for many years. So we've been in numerous space applications, so we can provide some of that space heritage data as well. Yep, electrical testing. This kind of goes through all the mill standards. I'm not going to bore you to death with those. Packaging. So we do waffle pack, and we also do the ring packaging. So we can do. You just see. Didn't realize there wasn't a picture of the waffle pack on there. It's just these are just two rings. But we do repopulated and we also do black dotted as well. If you don't know what that means, just black dotted means that they blacked out the bad parts, and you don't take them off the ring. We just kind of just identify them for you. Typically, we don't do that. It's more replacing with the good ones, which is it's an automated process as well, so we don't have an issue with that. Capital investments. So, I mean, Knowles is growing. We've been growing substantially since the years I've been here.
Hey, Ian.
Yep.
I got a question about the DC blocking caps.
Oh yeah.
Do you know the performance compared to the surface mount and loss and thermal?
For the DC block. Okay, so what part you want it to compare to? So
it just says DC block during the surface mount and loss and thermal.
So these are, yeah, this is Jarian. So basically these are rated for X7R characteristics. And they do range, I mean, these are, X7R means rated from -55 to +125 degrees C.
yeah, but did you ask for it to compare against a different part? I mean, that was I was kind of, or were you just asking for the thermal temperature coefficient?
Hi, can you hear me okay?
Yeah.
Yes.
Yes. Okay, good. I meant to ask I think it's 2 pages down from here. Yeah, so the DC blocking. So you're comparing to SMT components here. So for the same footprint, let's say 0602, I guess the thermal property that we're looking for, I mean, it's a thermal / loss. Sometimes we use this for high power application where the blocking cap ended up getting taking some heat due to its own loss and need to dissipate that heat. So it's in a way I'm asking one question, to I guess two things at the same time. One is the loss. And the other one is how do you take care of loss in terms of thermal perspective? So are you better at that in compatible SMTs or for the same size?
Yes. Yeah.
So yeah, I guess if you can that would be great.
Yeah. I think it's Hello?
I can hear you.
Are you hearing double playback?
Yep.
Hello?
Hey,
Can someone
Chris.
mute?
Yeah, I
Did
can.
that answer your question, Chris?
I guess I'm looking for more quantitative number compared to your competition. But I don't expect you have that right now, but sometime later on, if you have something like that, we'll be happy to try it out.
Okay. So Chris, are you looking at, these are characterized for ±15% over the temperature range.
Yeah, I'm really not interested in what the cap changes over temperature, but really whether these caps can handle the power under some power conditions. That basically loss of this cap will generate heat, and therefore that heat needs to be dissipated. It can be maybe your cap will have a higher operating temperature than other SMT components or something. So
Yeah, we can give you some data.
These
okay.
have
Well,
a
we can
dispersion factor of about 3.5%.
Hey, Chris, what we can have you we can do is have Megahertz Rep send you the data sheet over, and we can start with that conversation that way.
Yeah, we can do that later. Please.
Hello? Hello? Can you hear me now?
We're good to go, Ian.
Okay. Sorry. It's getting all terrible feedback. It was hard for me to understand what was going on. All right, we'll take that one offline. All right, so for the capital investments, we've made considerable capital investments in the recent years. Ceramic manufacturing, key improvements. We've added lapping and polishing machines. We've added new kilns, and we established a substrate stockage program. Basically, we make substrates ahead of time, so it reduces lead time for our customers. Our typical lead time right now for compacts is about 4 to 6 weeks, and for DLI is about 6 to 8 weeks. The reason for the additional time frame for DLI is typically sometimes testing, but we can get it down to 6. Typically, both are right now 6 weeks total. And depending on the testing and the testing requirement, we'll reduce that. Back in manufacturing, we've done a lot of capital investments for that as well. We've invested, $10 million worth of capital expansion of facility and past improvements. Really, that's a lot more on the manufacturing side for thin film, but where there's improvement there, then that means it's less stress on the single layer side. So it's an inverse effect of improvement for single layer, right? So all the people that we're focusing on both lines of product lines at the same time now really have to focus solely on the single layer, and it's just better throughput, better quality, and improved focus, all the things that kind of come through of just focusing on one thing. This is positions the capital investment and the increase in volume. This is an older slide I didn't take out, so I'll have to get this updated. But yeah, we position. This has not really panned out due to the great year of 2020 that we've had. But we basically maintained our year over year position. We haven't really lost business, so. But the growth really hasn't been there the way that 2020 panned out. I mean, there's a lot of factors. COVID played a huge role in that. And the high rel side, we're really large in the medical implantable devices, so that was on hold for many months, and we saw a decrease in volume in that, and also on the NLC side as well. The single layers has been pretty stable. Really not too much change there. And capital improvements, this is another one. So there's the things that we've been working on is the ceramic firings, the ceramic lap and polish, laser drill, lithography, dicing. All these are related to single layer and improve the processes and capabilities for single layer capacitors. So I finished up a little early. You guys have any questions, comments?
I mean, I don't see any in the chat. I mean, if you guys do come up with any questions or comments after the webinar, we can always go ahead and set up a follow-up call with your local megahertz representative. You can always get Ian on the line as well. If you guys like, you can go ahead and disconnect. Otherwise, we can see if there's any other questions that pop up.
All right. Thank you, Jason, for hosting this, and I really appreciate everyone's time. All right. Thank you.
Thank you.